continuing on with our rational functions, we're going to talk about multiplying rational expressions first. The idea is to factor, multiply, but not really, and then simplify by canceling common factors. So, simple one here, 3x over 8 subtract 2x squared. Let's go ahead and factor. So this is 3 times x times 2, and 8 is 2 times 4, and x squared is x times x. So because it's multiplication, we do not need a common denominator, so we can just multiply numerators and multiply denominators. But we don't want to make it any more work than we need to, so do not multiply for 6x and 8x squared and then factor. Just start factoring. And then look for our common factors that we can cancel out. Rewrite the remaining factors. And we've done our multiplication and simplified all in one step. This expression over here, we can't do much with the x plus 2. Let's see, it needs in parentheses there. The x squared subtract 1 I can factor to x plus 1, x subtract 1. That's our difference of squares. Down in the denominator, I have an x subtract 1 that was already here, times, and then the x squared subtract 4 is also a difference of squares, and it's going to factor to x plus 2, x subtract 2. And then we look for our common factors. So we have an x plus 2 in the numerator and another x plus 2 in the denominator. There's an x subtract 1 in the numerator and an x subtract 1 in the denominator, leaving us with the simplified expression x plus 1 over x subtract 2. That's not so bad, is it? Here's another one. It's going to take a little more work to factor, but one thing to think about is most of these problems are rigged. They've been written to have some common factors, and so if you can have an idea of some factors that are already there, there's a good chance there's going to be a similar factor showing up somewhere else. So by this I mean I've got a 2x subtract 3 in the numerator. Then also up in the numerator, 5x plus 5, I can factor out a 5 there as a common factor, and then leave an x plus 1. And then I have a 5 times x in the denominator, and this one's going to be a little messy. But I also know that 2x subtract 3 is already up here in the numerator. That might give me a good guess. If I'm going to factor this by guessing and checking, I know 2x squared would factor to 2x times x, and 9 might factor to 1 and 9, or 3 and 3. But I'm going to guess a subtract 3 here and then check, just because I have a 2x subtract 3 here. I could be wrong. That's why I need to do the check. If this is a subtract 3, this would need to be a plus 3 in order for these to multiply to equal the negative 9. And then let's see, 2x times x is 2x squared. 2x times 3 is 6x. Let's write that on the side. Negative 3 times x is negative 3x. And then, of course, the negative 3 times 3 gives me the negative 9. These do combine for 3x, which is what I was hoping to find as my middle term, so I do have it factored. So looking at my numerator and denominator, 2x subtract 3 is common, and 5 is common. That leaves me with x plus 1 and x times x plus 3. I would recommend leaving your answer this way. You could multiply out the denominator for an x squared plus 3x, and there's nothing wrong with that. But depending on what we might be doing next with some of these rational expressions, it's probably going to be more convenient to leave the denominator in a factored form. Okay, dividing rational expressions. Just a reminder, dividing by 2 is the same thing as multiplying by a half, and dividing by 2/3 is the same thing as multiplying by 3/2. So basically, when we're dividing by a fraction, it's the same thing as multiplying by what we call the reciprocal, flip the multiply. It's always the factor after the division that gets flipped over. We don't change the one before the division. That stays the same. And then we have 3 times 2, 4 is 2 times 2. We reduce and get our 3/2. Half and 3/4. Sorry. If we're dividing by 2, that's the same thing as We're dividing by a half, which is the same thing as multiplying by 2, so that value did double from what we started with. Okay, let me get some polynomials in here. So in a nutshell, when we're dividing these rational expressions, first flip, then factor everything, and simplify. When we flip over the expression that's after the division sign, that turns it into a multiplication problem, and then multiplication problems, we know factor, simplify. Make sure you do the flip first before you do any factoring, otherwise it's just too easy to forget partway through the problem that you're actually dividing rather than multiplying. So first thing, we'll rewrite it as 2x plus 2 over 6x. Again, the expression before the division does not change. It's the one we're dividing by that we flip, and that turns us into a multiplication problem. Okay, so then we can factor. We have 3 that won't factor. It's prime. We have a common 2 here. Undistributing that greatest common factor out leaves us with 2 times x plus 1. And then we've got an x plus 1 already in the denominator. And then 6 is 2 times 3 times x. So we can reduce out the x plus 1. The 2's divide, they're equal to 1. And 3 over 3 is a 1. Our only factor left here is x in the denominator, but be careful. Whenever the entire numerator cancels us out, we do need to put in a 1 as a placeholder. So our result is 1 over x, not x. Alright. Do you want to try this next one? And I'll pause for a moment, and then we can compare results. Okay, jumping back in here, I'm actually only halfway through the problem. So the division, the rational expression that we're dividing by, first thing I flip that over to change it to a multiplication problem. Then there was a lot of factoring, and I recommend factoring the parts that seem simplest to you first. So the 2x plus 1, I can factor out a 2 as the greatest common factor, leaving an x plus 1. The x squared subtract 1 here is the difference of squares, so I know that will factor to x plus 1, x subtract 1. X plus 3 is linear, so it doesn't factor. Just put some parentheses around it because I'm multiplying. And then the x squared plus x subtract 6, I saved for last, and it will factor to an x plus 3, x subtract 2. Once it's factored, here's the fun part, then we get to start canceling. The x plus 1's cancel, the x plus 3's cancel, and we see what's left. So I ended up with 2 x subtract 2 over x subtract 1. Okay, this one's pretty long and messy, isn't it? So again, first thing we want to do is rewrite the problem to change it from a division problem into a multiplication problem. And we can change it into a multiplication problem by taking the reciprocal of what we're dividing by. So taking what comes after the division symbol and flipping it over. It's important to take your time, write neatly. Nothing more frustrating than spending a long time, and accidentally doing something like I just did, where I had my 12, I accidentally wrote down a 2. There we go. So now I can factor, and again, factor the easy ones first. So I think I'll factor this numerator here and maybe this denominator here. Since they have the leading coefficients of 1, I think they'll be a little easier to factor. So x squared plus x subtract 12. Let's see, I think a plus 4 and a subtract 3 will do that. 4 times negative 3 multiplies the negative 12, and 4 plus negative 3 adds up to the understood 1 there in front of that x. I'll come back and take care of that later. I'll come back and take care of that later. I'm going to look at the x squared plus 7x plus 12. And let's see, 12. 2 and 6 will not give me 7, but 3 and 4 will. So x squared I know breaks down to x times x. And then I'm going to break the 12 down to 3 and 4. Everything's addition. So plus plus 3 times 4 is positive 12. 3x plus 4x is a positive 7x. Okay, now I'll try some of the harder ones here. How about this? 2x squared subtract 7x subtract 4. I can't always come over to the side of the problem. Use the edge of my paper to do some of the factoring. So 2x squared subtract 7x subtract 4. Let's see, that would be negative 8. So how about if I expand this out to subtract 8x plus 1x subtract 4? Taking a 2x out of the first pair, gives me x subtract 4. Taking out a 1 just as a placeholder, leaves an x subtract 4. And I've got an x subtract 4, 2x plus 1. So that I can take that piece over here. And my problem still flows nicely. So kind of have my scratch work on the side. Keep track of my overall problem here on the main part of my paper. I think that'll help me keep track of things. Let's see, 2 times negative 3 is negative 6. So probably subtract 3x. No, is that going to work? Oh, whoops. Okay, I've got a typo there. That's a 5. Okay. So, when in doubt, go back, check the original problem that you've written it down correctly. Okay, 2 times negative 5 is negative 10. Negative 10, I can make it negative 10x plus 1x, and that matches my negative 9x. So again, I can factor 2x out of the first pair, that leaves x subtract 5, plus 1 out of the second pair is also an x subtract 5, and that leaves me with x subtract 5. I need to be more careful how I write my 5s, don't I? And 2x plus 1. So x subtract 5, 2x plus 1. Now's the fun part. Looking for some common factors to cancel out. So as long as I have one in the numerator and another common factor in the denominator, doesn't matter if they're directly above each other or not. X plus 4, 2x plus 1. Let's see, I think that's it, because that one says x subtract 3 is not common, is not the same thing as x plus 3. So I'm left with x subtract 3, x subtract 4, over x subtract 5, x plus 3. Okay, happy factoring.